The last section in chapter 10 is on the area of circles and their sectors, which means their pieces. A sector of a circle, by definition, is a region of the circle that is bounded by the arc on one side and two radii on either side of it. It is basically a pie-shaped piece of the circle. Hopefully you remember the formula for the area of a circle. Pi times radius squared is the formula. A quick review: if you needed to find the area of a circle with a radius of 10, you would simply take pi, which is 3.1415, times 10 squared, which would give you 314.2 square millimeters. Hopefully you remember how to do that. So 10 squared is 100. 100 times pi would give you 314.2. Your book may ask you for the exact answer, and in that case, in the exact answer, you would simply leave it as 100 pi square millimeters. This is the exact answer. This is the rounded answer. The area of a sector, since it is a fractional part of this area, you simply take the fractional amount of the sector and then take that times the area of your circle. To find the fractional part of your circle, you will take the measure of the arc in degrees, how many degrees the arc is, divided by 360. Again, that will give you your percent of the circle. How much of your circle is your sector taking up? And then you use that and times it by the area of the entire circle. I can see my 360 has slid. It's supposed to be over here. So to find the area of just a sector of the circle, the area of the entire circle would be pi times radius squared, but to just get the area of a sector, you'd take your degree of your arc divided by 360 to get that proportional amount or percentage. And then you take that percentage times pi times radius squared. That's how you get the area of a sector. Just take the area of the circle and times it by what percent of the circle the sector takes up. Those are the two formulas that we're going to use today. The basic area formula for a circle, pi r squared, and then the area of a sector, which tells you that you have to take the percent of your circle that the sector takes up and then take that times the area. Does not want me to change. There we go. All right, some examples that you're going to see. Oh, it's going to switch me to another page, I believe. We'll just keep going until it does. To find the area of the sector ACB, notice this is a pie-shaped. We call this the sector. To find the area of that, you simply take how many degrees the arc is. Remember that the degrees have the same, or the arc has the same degrees as the central angle. So we would take 100 divided by 360, that gives us our percent of the circle, times, and then the radius is 6, so 6 squared is 36 pi. So 100 divided by 360 gives us our percent, and then times 36 pi. Our exact answer, leaving that in exact terms, would be 10 pi, or if it asked us to round it to the nearest tenth, we would actually take 10 times pi and get 31.4 square meters. That's how you use the formula for finding the area of a sector. To find the area of a smaller piece, for example, this little dome-shaped piece right here, it's a part of the sector. It is connected to a triangle at the center, and then together they make up the entire sector. But if I just wanted to know what this small piece was, I would have to take the area of the sector, the entire piece, and then I would have to minus off the area of the triangle. Okay, the area of the triangle, that's a review from earlier this chapter. So to find the area of this, first thing I would do is find the area of the entire sector. So I would do exactly what I just did above. I would take 90, because that's my degrees in my arc, 90 divided by 36, and then times radius squared times pi. So 13 squared is 169. I'd take 90 divided by 360 to get my percent, times 169 pi. That gives me 42.25 pi is my exact answer. To find the area of my triangle, the easiest way to do that is to use that formula that we learned in section 10.5, which was on finding the area of the triangle when they don't give you the height, because you won't have the height of this triangle. So you will use the 1/2 times side 1 times side 2 times the sine of the angle formula that we learned in section 10.5 to find the area of our triangle. Since we know both sides are 13, they're both radii, they'll be the same. I would take 1/2 times 13 times 13 times the sine of my angle. 1/2 times 13 times 13 times the sine of 90 comes out to be 84.5 square centimeters. So to find the area of this little bit, I'll take the area of my entire sector, which is 42.25 pi, and minus off the area of my triangle, which is 84.5, and that would be the exact answer, because this one has pi and this one doesn't. I can't put them together. Or if I was going to round to the nearest tenth, I would multiply these together and then minus off the 84.5, which gives me 48.23 square centimeters. Those are the two kinds of problems that you're going to see today using the area formula for circles. Your homework is on the next screen, which it may or may not let me get you to. Apparently it does not like. There we go. There is the homework for this section.